we focus on the programming side, but in this course we focus on the different types of system software, and we will try to understand what we have underlined of the system of the machines machines computers we have. But at first, tell me what is different from a system software. We normally say system software or applications. So what is the difference between the system software or system programs and the application software? Anybody can tell me? What difference between we normally say? Okay.
Can I answer? I think application softwares are software that provides a service to end user, such as us, and system software are the messenger between, or the interpreter between hardwares and application softwares.
Oh, right. Actually, you said right. Applications or application softwares are software that provide some service to the users. But system software, the main part of system software is to serve the application software. That is, they provide a platform for the system software. Actually, there are two different types of system software. One is to provide the service to the application software, and the other is we can consider some another aspects of system software as the softwares which help you to create an application. For example, compilers or linkers or even some text editors, IDE, is also considered as a part of a system software in that sense, that help you to make an application. So here we will try to understand the different kinds of the system softwares, and maybe the biggest system software we have in a system is operating system. Operating system is we can consider is one piece of software, one programs, actually understanding the operating system is a very difficult task, because this is a very complex systems. In this course we cannot understand the whole system software, but we will try to analyze some part of the operating system. Okay. Now, here is some informations from me, and my name is Nguyễn Hữu Đức from the Department of Information System of SOICT, and actually I have two blacks in HUST. The one is lecturers from Department of Information System. The other is to serve as directors of the Centers for data and computation technologies. Maybe people know best about these centers as high-performance computing centers. I mostly focus on the high-performance computing and parallel computing or distributed computing or cloud computing, something like this. Okay. And if you want to contact me, you can use my email address like here, mobile like this. But this is just official email from the school. However, if you want to email to me, I prefer to use another email specialized for SOICT persons. So I will write in the chat like this. Okay, SOICT. Or sometimes you can even write to my personal email on Gmail, like the personal informations are contact informations of me, and you can write me an email, or for emergency case you can call me on mobile. And of course, for this course, if you want to discuss about some things related to the course, I prefer that you drop some message on Teams. We use Teams as a centralized place for discussing the problems, the issues in the course. So I can follow easier on the Teams instead of reading a bunch of email on my mailbox, which is awfully full. So if you want to ask some questions related to the course, so please drop some message on Teams. Okay. And for my personal informations, I'm also graduated from the HUSD, but a long time ago. I graduated HUSD since 1990. I entered to HUSD on 1991, and I graduated in 1996. And after that, I take 2 years for master thesis for my master programs, and after that, I take 3 years more for PhD course in Japan. My specialist is in PhD course. PhD programs is about the compiler constructions. I wrote some compilers for a specialized language, which is a functional language. And because of this, I a little bit understand about the how programs can be made. Because I have to write compilers for a specific language. So I need to generate the binary code for that language to be run on the system, because that I have to understand the how a program works underlying under a specific system. That's why when the HSP program start, do you know HSP programs? Japanese speaking program in SCSD. Maybe you know, right? In Vietnam, we call that Việt Nhật. Okay. When HSP program start, maybe in about the 2007. I do not remember exactly the moment, but more than nearly 15 years from now. And when when HSP program start, and I am also the person who works with Japanese expert to make this course, to make the syllabus, of course, prepare materials for this course about 15 years ago. And maybe I don't know how about the near futures for this course, because in near futures this course has not yet present on the programs, but it still remain on your class right now. Okay. So because I graduated from the Japanese institutions, and in my master thesis I studied French. So this is a big. This will have some problems in the English speaking to you. So please apologize if my English is not so good. Okay. Okay. Let's come back to the lessons again. So we have 15 weeks for the course. 2 sessions, 2 hour theoretical hour for lessons for a week. Not so much, but I hope that we can still get something, some information, some knowledge related to the course to you. And sorry about the code. This is different now. I too lazy to update that information. And the as you see that system software is computer software designed to operate the computer hardware, provide the platform for running application of software. This is the general descriptions for system software, and we will objectives for the course is to master the role, the functions, and the structures of system software, especially for the operating system. And we need to understand the relationship between the system software itself, because the system software they normally have to interact among each others to provide the service to the applications. And one big part of the course is also we need to understand the structures of the an application software. Why we study the system software, but we need to master the structures of application software. We do not try to study the structure of the application software in a higher level. High level is in a higher level of programming language. We do not try to understand this, but we try to understand the structure of the application in a very low level, the level which is have to interact directly to the system software. So this is very important to understand the low level of low level structures and application software. And for example, you need to understand the structures of a binary executables. For example, when we compile a C program to a binary code, and then you need to study the structure of that binary code. What we have inside that binary code, what is the instructions inside that binary code, which is also related to the assembly language. Try to programs in assembly language in this part, but we need to understand the assembly language as expected. Okay, so and the last part, of course, is a little bit difficult to most of you know how to develop your own system software. Very difficult to develop on system software, but we can do in at some level of the developments. For example, we can try to develop a newer system call to an operating system. We can try to develop some device drivers, or we can try to make some change in the kernel code, maybe. But this is upon you. I will show you the principles of these things, and you can, if you are interested in this part, you can try to learn by yourself. Okay, the materials. We do not have the Vietnamese materials or writing materials by ourselves yet. But if you prefers to read more, so we can refer to several books as I gave you here. The Linux kernel, a very important part for the system software, the operating system, and this there are many versions for the Linux kernel due to the evolutions of that kernels. So you can find this with the we can take the newest versions for Linux kernel. And the second book is related to the linkers and loaders. Do you know linkers and what is linkers or what is loaders? Anybody, what is linkers? Do you know linkers?
So may I answer?
Yes, please.
I know what a linker is. It is a program that combines objects that are generated by the compilers and create a executable program from those objects.
Yes, that is. These linkers are programs to combine the object code together to make executables. So this play a very important part in making the programs. But linkers normally the linkers are hidden from us. For example, we used to compile programs to directly to executable tables by some shortcut. For example, you use GCC, you just directly make the executables from source code. But that shortcut from GCC is combining several steps, including the compilations and linking. And that means GCC is also providing us for us. So even that when you use the an IDE to programs, you do not needed to know about the linkers, because your environments, your programming environment also provide that linkers behind the scenes to you, right? But if you have to do some large scale projects, so your piece of code will be distributed to all the member. In this case, you need to make something like a separated compilation. That means each member will develop some piece of code, and then they can they can make an object code from their works, and then they gather the object code together and make a linking. So this is the this is referred to terms of separated compilations in the technical terms. So linkers or linking process play a very important role in this separate compilations. And the others, another system programs, actually this is a part of operating system. In most of operating system, it's a loaders. So what is loaders? Loaders is separated programs, or sometimes a part of operating system, which is help you to read your executables in the form of a binary file, right? Read the executables, put it on the memory, and then try to run this from the memory. So this is also very important part because this is the kind of entry points for running every application. Whenever you run application, even from cells or even from by interactively by clicking the icons of the applications, you actually invoke the loaders. Okay, so now we need to understand how linkers work and how loader works. This is the contents of the second book. I give this to you, and also I will explain in the course. The last book is related to another kinds of system software. Actually, this is also a part of. We can consider this also a part of operating system, which is device drivers. Maybe we consider this a separate part of operating a part of operating system, but we this is developed not by the inventors of operating system, but is developed by the third party. For example, you have some new device. You need to connect this new device to your computers, but how to control your new device? Of course, operating system cannot know everything, right? Operating system can only understand some principles, can propose some principles, some interface. So the companies who create a new device, we have to provide to you the device drivers that are compatible to the interface, and implement the way we need to use your new device. So in device drivers, we will understand the this how to create that such kind of device drivers under Linux. Please remember that most of contents in this course is related to Linux system, Unix or Linux system. So maybe you can prefer more about the Windows, but let us specialize this course to Linux because it's open source, so we can analyze the inside structures of Linux is more easier than Windows, which is proprietary software. Okay. Now there are some requirements for students in this course. Of course, I expect that you have a full application participation for everybody, and according to the academic rules, we cannot skip or some portions of the class, and during this this course, I also have some homework, some exercise for you. So in this case, you need to show off when I call you to do some exercise. This is of course we have very big class. I cannot check the assignments for all of the class. It's just a waste of times. But I will randomly pick some of you to answer the question if we have. For the midterm evaluations of the course, actually there are two kinds of midterm evaluations. The first one is you need to make a long-term projects. The projects for whole long the course in the semester, and maybe you can choose some programs related to device driver, which is most preferable for course projects. For example, you can make some special device, and you want to control that special device from your computers, and you. So I expect that you will write some drivers to your special device. Sometimes you do not need a specific device to control your device driver to control your device, because they use some existing interface, so you can just reuse that existing interface to control your device. Maybe that's also fine, because you also need to do programming in that low levels of okay. But by the way, the long-term projects is about the writings or making some system software, such as system call device drivers. And if you have a very complicated projects and which is needed to do with your friends, you can make a teams for your projects. It's also fine. So here is the columns of the okay. The evaluations for the midterms is 30% of the cost, and the final examination is 70%. And actually, I will try to ask you about it, that midterm evaluations. You can do either in long-term assignments, or you can make some examinations, midterm examinations. But that is that's up to you. I will try to make the try to ask you about these opinions. Okay. Okay. Now this is some general information for the course. So in the above, you have a simple definitions for the system software or system programs. Now here is more details, more concrete definition you can find on computer dictionaries. The system software is any software required for support productions or executions of application program. So here you have two parts: productions of application program and execution of application programs, right? Um, Systems typically include an operating system to control the executions of other programs. The user environment, so as a command line interpreters, the Windows system, desktop system, etc. The development tools are for building other programs such as assemblers, um, compilers, linkers, libraries, interpreters, uh, cross-reference generators, versions controls, uh, make debugging, profiling, monitoring. All is generated related to uh, uh, the productions of system of application software, right? Uh, some other tools also considers as system software. For example, we have some packing tools, some sorting, some printing, even some editing tools. It's also considered as system software. But we will try to consider the systems software which is related to that two roles, production and the management of execution application. Okay, that one very difficult question to answers, even to you, even to me. Why we have to learn about system software? Uh, because nowadays uh, uh, almost everything are already provided to you. All most aspects of system software are hidden behind a very high level interface to the end users. You do not need much for studying the system software anymore if you just want to use the user programs. Sorry, wait for a few minutes. Sorry. Uh, let's come back to questions. Why we need to study system? So why when most of the times we do not need uh, uh, to know about the system software to understand the system software. Uh, However, uh, uh, in our jobs, in IT jobs, we have different target. Some people target on the developing some some applications using a high-level language. Some people want to be a data analysis, and in some sense, you do not need to understand much about the system programs or system software if you place such kind of roles. But still, some people want to work in a lower levels. For example, you want to make you want to make some device. You want to make some a new device. You want to make some peripherals. You want to create an adaptable operating system to use. So in this case, you need to know about the systems. And I will tell you the biggest reasons why we have this course in your programs. The originals of this course is from the HASP programs, and you know that the HASP program is designed for providing the initial designs for the HASP programs is designing for the IT human resource, to provide the IT human resource for the Japanese market, for the Japan. A very specific target. The Japanese government at this time realized that they don't have enough the IT engineer, especially IT engineer in a low level, like system software, like working something with system software. Because of that, they invest in the country like Vietnam as a human resource source to them, and they have some requirements to this HASP programs. And if you look at the HASP programs and also a part of your program now, you will see there are a lot of very low level courses, like system programs, like compiler constructions, like even compiler construction is divided into compiler construction and compiler construction experimentations labs. A very low level, because of the requirement for the human resource for the IT engineer in the Japanese market. So this is the reason why we have this course in HASP programs. And after that, the SOICT opened a new programs which called ICT. That means you. They inherit the materials, most of academic materials from HASP programs. Just apply the the curriculums from HASP program to the ICT, adding some or remove some, but very little. Most come from HASP programs. And in these new curriculums, the system programs still remains. So this is stories about the curriculums of ICT. And of course, there are some things is not much suitable for now in the ICT programs. Even in the HSP program, we are making a new curriculums to the new programs of the new curriculums for ICT as well as HSP, and as I realized that in that new new curriculums, we get targeting for something more interesting, more up-to-date topics. We do not have to receive the money from the Japan anymore, but so that we can design the curriculums by ourselves. Low levels information like system software will be disappear from a new course, new curriculums. But this is a little bit pity because that's also something interesting in this. Okay, that is a little bit stories about the this is more some more informations about the system software. So why we learn about system software is to bridge the gap of knowledge between the application software and computer hardware. Because most people know about the application software, know the platform for developing application software in a very high levels, but what they do behind that IDE, that very complex IDE, and that very beautiful high-level language, but how they make this to run another systems, this is what we will try to understand. Next, to understand how application software are created, which is consisted in as application binary. This is we will try to understand. Next, to have knowledge to build a specific system software like device driver. Of course, maybe in the future, some of you will have to make a new device drivers for your new device. So in this case, you need to know how to build a device driver for your new device in order to integrate it with this with the computers or a computer system. Okay, this is the reasons why we need to learn about the system software. This is general flows of making applications. We have two big phase for making applications: the compilation phase and the linking phase. So providing a source programs, compilations, compile a compiler to make a objects program from that source programs. This is also make object programs, and then you can link these object program together and together with the libraries to make executables. So this is two separated parts of making an application survey. Of course, this is following the compiler approach, right? Today we take an alternative approach for executing a programs with interpretations. We have several interpretations language like interpreters language, for example, Python, R, PHP, something like this. This take another approach, a little bit different approach. But if we want to make a binary applications, normally you have to do this. Okay, maybe I will write a very simple code to you to some of you know about this, but some might not. So I will show you the let us start from a very simple example, the hello applications. Let's make some hello application, right? Can you see this? Okay, I will make this a little bit more bigger. Normally, when you want to make that programs, you you normally just write, for example, you need to GCC minus O test from test.c. So you just make this, right? But actually, this is just a shortcut. This command is just a shortcut. This is combinations from a compiling process. For example, you need to do some compiling like this first, and this is the result to an object file which is called test.o in with GCC, which is object file from this. And next part, for example, if you have for example, here you have a function add, and I'll make that two functions here. And you want to use and you just for example, uh, of course, here you have two programs, test.c and a.c. If you want to compile this inner at the same time to make executable, so you just call gcc minus o test and you give test.c and a.c. So this will be give you the executables in the binary text, right? But what happens if you have two persons? The first person develop test.c and the second person develop a.c. They cannot they cannot do your programs at the same times. They develop this separately, and sometimes they want to to debug or want to so in this case we can separately compile the test.c and a.c, like gcc minus c test.c to get the test.o, and you can also do the same things for a.c to get the a.o, and after two separate things like this, we can combine that two things together by gc minus o a.o and b.o. Sorry, test.o. Something like this. That means you combine the a.o, test.o. Actually, not only test.o and a.o, it's also have some library inside that linking. So this is linking. This compiling, and this one is linking. Yes. As I just told you, you might not realize that if you only develop your programs under an IDE, you do not realize this. Okay. Here is some actually for linkings. GCC minus O is also a shortcut for linking. Actually, they use some standard linkings like LD. You can maybe you can see this LD. This is the this is standard linkers for Linux, and this is included in most of operating system as an utility part, system utility part. So actually, GCC is just to reuse that LD program to do this linkers. However, if you want to use directly use LD, it's also fine. However, you need to specify not only the a.o test.o, but you need also specify some libraries and some special initiations and cleanup object files, which is a little bit complicated. I will try to explain this to you later when you go to the linking part. Okay. So this compilations and linking. Okay. How we execute a system software? In order to execute a system software, you you have an executable file, and then you use some loaders to load that executable file into the memory, right? And then from the memory you run using the machine, you run the execution, run the instruction. You run when you run instruction, you might need to provide input, and this produce the output. This is the normal flows for executing the system software. And this is a structures diagram for to understand the interactions between your programs and the operating systems. Actually, your user programs will have to use some functionalities from some functions from your libraries. There are something like dynamic libraries, something like static libraries, but we generally call this libraries. And of course, in order to use the common resource of the system, such as the screen or keyboard or mouse or something like this, you need to interact this to the operating system. And operating system will provide a set of service to the user programs, and the interface for such kind of service we call that system calls. System calls are kind of interface to the user programs. For example, if you want to access to some file to the file system, any file system, you need to use some functions like open, close, read, write, etc. This is the actually corresponding to the system call. I will tell you more about system call later. And inside, when you when you request some service from the operating system, you need to go through the system call, and a system call will interact to the other part of the operating system to serve the user request. For example, if you ask something about the process management, like I need to kill some process, I need to make a new process, something like this. So this will redirect your call, your request to process management. If you want to access to some memory, for example, you want to allocate a new block of memory, so system call will redirect your request to the memory management unit. And if you want to access to the to your file systems, so they will go through the virtual file system first, and then decide what is concrete file system we want to access. So this will go through this virtual file system, and then go to the concrete file system. And if you want to access to some device drivers, some device, you know that Linux device and 5 have the are considered very similar. For example, you can find the your device in the directory. For example, we let's see dev. You see that we have plenty of device here, and they are considered as the the 5. So actually, the interaction in Linux, interactions from the applications to device are considered as similar to the interactions of the user to 5. You need to open a new device drivers. You need to read, to write, to control to your device, and after that, after finish working with device drivers, device, you need to close the device. So so actually, to use the device under Linux, you use the same interface as a file. But the virtual file system will switch to your concrete device instead of your file system. That is okay. So in principles, in your Linux kernel, we have several parts here: process management, memory management, virtual file system, and network stacks, and device driver. That is the main components of operating system. Sorry, let me check. Okay. This is a little bit explaining from these diagrams and the previous diagrams. For example, explaining for source programs. You know that a source programs is original computer program written by programmer in plain text format. You read. You make a new programs in plain text. That the computer program might be consists of 1 or more files. 1 or more files. So as just an example, I just gave you, I developed source program into 3 separate files: 2.c and 1.h, right? So that is source programs. And source program is written in stack of one of or some language. Sometimes you write it in totally in C. Sometimes you develop it totally in Java. Sometimes you develop it totally in Python. However, in more complicated applications, you may have to write your program in different language. For example, you one piece of code you write in C for performance, or some piece of code you write in Python, some piece of code you want to write in Java. How to combine these things together? So source program be edited by tools such as text editors or some IDE. About this one, of course, Most people prefer to use IDE to develop applications. It provides very nice features in IDE, such as um, uh, auto code suggestions or highlightings or something like this, or some. But you know that most of system programmers or system engineer, they don't want to use the IDE. They don't want to use Microsoft Visual Studio or Eclipse or NetBeans or something like this. They want to use some simple, as much as simple as possible. For example, they use VI for editors and so that or Nano for editors, something like this. For me, I prefer to very interesting tools with Emacs. I may use Emacs as my coding tools. I can use Emacs for emailing tools. I can use Emacs for instant messengers, etc. I can use Emacs for a lot of purpose. What is upon you? Source program be compiled into object code by the compiler or executed on using the interpreters. So that is a source program. Here is a simple source programs, and what do you have in that simple? Of course, this program cannot be executed directly onto the system. You need to it needed to be compiled and linked to get executive code, because this code cannot be loaded in the memory for execution. Of course, we can only load for execution. We can only load the binary code. In this code, it does not include the implementations of the function printf. This printf comes from the standard library for C. So some people mistake that when you do include stdio is that you include the library. No. This include stdio is just also include the prototypes of the function, several function. That's several functions, including the printf function, prototype printf function. We can find this in stdio. So this is just the prototypes, not the actual implementation. The actual implementations of printf should be realized in a library like libc. We have libc, which is consists of several standard functions for the for C. So we have libc. So this is just some characteristic of the source programs. And, the next, the objects programs, is the output for the compilations of source programs, which is usually presented in a machine language. Please note that this is objects program normally written in corresponding to the specific architectures, processor architectures like Intel's or MIPS or something. For the that objects programs, if you write the objects programs, you will have some in that code. There's something some might be like, for example, when you call here the function printf, but since you compile the function printf separately, so the reference to printf will not know at the compiling times. So in this case, at that's call for the functions, we don't know the address for the call function call. And object, because some lacking information, address information like this, the object file cannot be loaded into memory and executed. We can only load and execute the executables, not object programs. So here is the example. You see that in a example of the generations of the above program in x86 architectures. I mean AI 32. So you see that this is the instructions to call the function printf. But this is not the address of the function printf. This is just a random value, which is taking the location from the main to that position. That is not the address of function printf. The address of function printf all can be filled when we do link. So that is the okay. This is also the end for we can stop here because we have a next class in 5 minutes, 10 minutes. So let's come back to next week. Okay. Hope that we will have nice working to all of you. See you.
Goodbye, teacher. Thank you, teacher.
Okay. You have some questions, Anna? Okay. See you next week.